Have you ever stood over a golf putt just totally confident you had the line,
Oh,
and
absolutely.
then you watch it just drift away from the hole? Or maybe you hit it perfectly, you think, but it rolls like 10 feet past.
Happens all the time. It's maddening.
It really is. It's what makes golf, endlessly frustrating, but also fascinating. So today we're doing a deep dive into the hidden science behind something that really feels more like an art form, doesn't it? The golf putt.
Hmm.
We've got our hands on some really fascinating data, actually. Kind of rips back the curtain, showing exactly how green speed, the slope, and your initial angle, how they dramatically impact where that ball ends up.
Yeah, it's pretty detailed stuff.
It really is. And our source material for this deep dive, it's not like a long article or a book. It's actually a series of meticulously compiled dated
Oh, it's
tables.
almost like lab results.
Exactly. Think of them less like, casual notes and more like, well, scientific experiments. They track the ball's behavior under very specific, very controlled conditions. So our mission here is basically to unpack these numbers, translate them into insights you can actually use, maybe, and honestly, just kind of marvel at the pure physics of it all.
Yeah, the physics of motion.
For anyone curious about golf or just how things move, really, it's kind of a shortcut to understanding the green in a way maybe you haven't before.
That's right. And what we'll be exploring are three core variables. First, there's stimp distance. That's just the standard way to measure how fast a green is.
Right, the higher the number, the faster it is.
Exactly. Higher
Mm.
stimp, ball rolls further. Second, we've got inclination. That's just how steep the slope is.
Okay.
And finally, the angle of the putt. Specifically, the angle you hit the ball relative to the slope's fall line.
The fall line being like where water would drain down.
Precisely. And crucially, in all these scenarios, the ball is consistently struck with a target speed, 3 burps.
3 revolutions per second. So the initial hit, the energy is always the same.
Always the same initial forward roll. It means we're stripping away, the human factor, the variability in the stroke itself. We're focusing purely on how the green affects a perfectly struck ball.
Gotcha. Isolating the environment.
Exactly. And for each scenario in these tables, you get a horizontal distance, usually in meters, and then a set of values. You'll see these A and B values.
Uh-huh.
They basically quantify the lateral movement, the side-to-side stuff the ball does because of the slope. It tells you how much the putt will break.
Okay, the break.
Then there's a really important third value, C. That's the total putt length in meters, how far it actually rolled. So these tables give us this incredibly precise, almost like laboratory-level look at cause and effect on the green.
Right. Isolating the variables, like you said, gives us clear insights.
Yeah.
So, okay, with these variables, stimp, inclination, angle, where do we even start trying to untangle all this data?
Well, maybe let's start simple.
Yeah, good idea. Like,
Yeah.
what happens when you hit it just straight up or straight down the hill?
Perfect. So that's what the data calls 0 degrees. That's straight downhill, and 180 degrees, which is straight uphill.
Oh, okay.
For these putts, the perfectly straight ones, the tables just show NA for those A and B values.
NA meaning not applicable, right? Because there's no sideways movement.
Exactly. No lateral component to worry about. So we just have that total putt length, C.
Makes sense.
And even just looking at these straight putts, the impact of that stimp distance, the green speed is, well, it's immediately striking.
How so?
Okay, imagine you're on a really fast green, say a 13-foot stimp, compared to a slower 10-foot stimp. Both have just a gentle 1% downhill slope.
Okay.
If you hit a putt that covers 1 meter horizontally on that fast green, the ball actually rolls 1.44 meters total.
Wow.
But on the slower 10-foot green, it only goes 1.27 meters.
That's almost 20 centimeters difference just on a 1-meter putt.
Exactly. It really quantifies how crucial green speed is for distance control.
Yeah.
It's not just about feel.
Yeah, absolutely. Imagine that difference over a 20-footer.
Right. A slight misread of the speed could easily turn what should be a tap-in into a 3-putt situation.
Easily. Okay, so that's speed. What about the slope itself, the inclination on these straight putts?
Well, let's stick with that 10-foot stimp data. Straight downhill, 1 meter horizontal distance again.
Okay.
At a 1% inclination, we saw it rolls 1.27 meters. But if you increase that slope to a steeper 4% inclination, the ball rolls a surprising 1.67 meters.
Whoa, nearly half a meter further just from a steeper slope with the same hit.
Same initial effort. It just shows how much that steeper downhill slope adds distance. Gravity really gives it a push.
Gravity is definitely your friend going downhill then. But what about the other way? When you're fighting it going straight up a slope, we all know that feeling like you're hitting into a wall. Does the data back that up?
Oh, absolutely. Let's look at the 10-foot Stimp data again, but this time for an uphill putt, say one covering 8 meters horizontally.
Okay, longer putt.
Right. At a gentle 1% uphill slope, the ball rolls a total of 7.13 meters. So it doesn't quite make the 8 meters.
Right, loses almost a meter.
But keep that same initial hit, same target speed, and increase the uphill slope to 4%.
Yeah.
The ball only rolls 4.06 meters.
Less than half the horizontal distance, it rolled over 3 meters less.
Over 3 meters less. Yeah, it really is like the green is just eating your putt, like you said.
No wonder those uphill four-footers feel like they need a sledgehammer sometimes. The data totally confirms it. That steeper uphill slope just drastically cuts down the distance.
It kills the momentum.
Okay, so straight putts are clearer now. Speed matters, slope really matters. But, for most of us golfers, the real headache, the true mystery, is the break.
Ah, yes, the breaking putts.
Oh, and it's not straight up or down. That's when those A and B values you mentioned come in, right?
Exactly.
Those represent the lateral movement, the side-to-side drift.
Yeah.
Essentially how much you need to aim offline.
That's a good way to put it, yeah. The required aim adjustment to account for the slope.
So how do these A and B values actually help us understand why putts break and what makes them break, more or less?
Well, what's really fascinating here is how dramatically those A and B values change with both the angle you're putting across the slope and the steepness, the inclination.
Okay, give me an example.
All right, let's take a 1 meter horizontal putt again. Fast green, 13-foot Stimp.
Got it.
If the putt is just slightly off the fall line, say 15 degrees, with a gentle 1% slope, the AB values are 0.05, 0.39.
Okay.
Now change the angle to 45 degrees, so more across the slope, but keep that same gentle 1% inclination. The values become 0.05, 0.35. Not a huge change there, interestingly, but keep that 45-degree angle and now crank up the inclination to 3%.
Right.
Much steeper slope.
Right.
Now those AB values jump to 0.15,
Okay.
0.54.
So the A value tripled, 0.15,
Yes,
that's
sir.
15 centimeters, right? Over just 1 meter.
Exactly. That means you're aiming 15 centimeters, roughly 6 inches outside the hole, just for that initial meter of travel because of the break.
Wow.
It really quantifies that as the inclination, the steepness gets bigger, that lateral pull, the break, becomes much, much stronger.
That makes intuitive sense, but seeing the numbers is pretty stark.
And here's where it gets really counterintuitive sometimes. You'll actually see negative B values in the data sometimes.
Negative? What does that even mean?
Well, look at this one. 13-foot Stimp green again. Angle is 105 degrees, so significantly uphill and across. Inclination is 1%. For a 4-meter horizontal putt, the B value is negative 0.07.
Minus 0.07. So a negative B doesn't just mean a small adjustment. What's it suggesting?
It suggests that on certain sort of complex breaks, your intuitive aim might actually need to be, well, against the break, at least initially.
Aim against the break.
It could mean the ball's path is so strongly affected by the combination of angle and slope that it kind of defies a simple left or right read. You might need a completely counterintuitive starting line just to get it on the right overall path.
So the slope can be so dominant from certain angles, it almost pushes the ball somewhere unexpected first.
That's one way to think about it, yeah.
Yeah.
It implies a situation where the curve isn't simple. It might even have a bit of an S-shape quality to it, starting one way before turning back.
Wow, okay, a negative B value. That's genuinely surprising. That really changes how you might approach some putts, thinking about that initial move.
It does.
And if you look closely at these tables, you also notice, don't you, that the A and B values, they tend to get bigger as the horizontal distance, the XB value increases.
Absolutely. Good spot.
So what that means in, like, plain English is just that longer putts break more, right? They're way more affected by the slope's lateral pull than shorter ones.
Precisely. So that maybe 5-foot side hill putt might break a little bit,
Uh-huh.
but a 20-foot putt on the exact same slope, same green speed, will break a lot more. It's not just 4 times the break because it's 4 times the length. It's often more than that.
It's exponential almost.
It can feel that way.
Yeah.
It really explains why those long breaking putts are such a nightmare for everyone. The potential error just gets magnified.
Definitely. Okay, so if we try and connect all these dots, what this data seems to be screaming is that stim speed, slope inclination, and the angle you putt at, they don't just work on their own.
Not at all. They're deeply interconnected. They amplify each other or sometimes diminish each other's effects in complex ways.
So a fast green, like a high stimp, plus a steep slope at a sharp angle across it, That's going to be a wildly different experience, a much harder putt than, say, a slow green with a tiny slope.
Vastly different. And these tables quantify exactly how different. Each factor is dynamically influencing the others.
So, okay, pulling it all together,
Yep.
what does this actually mean for someone standing over a putt on the course? Like, what's the takeaway?
Well, I think it provides a quantitative basis, a numbers-based reason for understanding why a putt breaks, how much it does, and how far it's likely to roll.
Right.
It highlights how absolutely vital it is to factor in not just the length, but the green speed and the precise angle and steepness of that slope. It sort of turns the feel or the guess of reading a putt
Yeah.
into something closer to an objective, though still complex, science.
It really makes me question how much I've just been, relying on gut instinct when there are these measurable forces at play,
Yeah.
leaving a lot to chance, maybe?
And remember, this all comes back to that constant starting point, that target speed. 3 chimps.
Right. The consistent initial hit.
What that tells us is that these tables are really describing how the environmental factors, the stimp, the inclination, the angle, how they change the outcome, assuming your stroke, your initial effort, is perfectly consistent.
That's incredibly valuable, isn't it? Because it isolates those variables. We can see their effects without worrying if the difference was just because someone hit it harder or softer.
Exactly.
Yeah.
It's like taking the variability of your swing out of the equation just for a moment to truly see the green's pure impact on the ball.
Okay. So we've taken quite a deep dive into these tables, and honestly, I'm just struck by how much intricate data and pure physics goes into something that looks so simple from the outside, like a golf putt. It's way more complex than just hitting the ball towards the hole, isn't it?
It truly is. It highlights that, yeah, a perfect stroke and consistent speed are crucial, definitely. But really understanding the green's characteristics, the subtle stuff, or sometimes the not so subtle stuff,
Yeah.
that can genuinely be the difference between watching it lip out and watching it drop.
Yeah. Knowledge of that environment really is power on the green.
It really is.
So I guess the next time you're out there on the green, or even if you're just watching golf on TV, maybe think beyond just the length of the putt. Consider the stimp speed, the exact slope, that angle of approach.
Yeah, they're all working together.
They really are kind of dictating where that ball is going to end up.
Mm.
So maybe for you, our listener, here's a final provocative thought to chew on. If a consistent initial force, like that 3 arps putt, can lead to such wildly varied outcomes just based on the environment, the green's characteristics, well, what other everyday actions do we perform where subtle environmental variables might be having a much bigger impact, maybe an unacknowledged impact, than we realize?
That's a great question.
Yeah, something to maybe mull over until our next deep dive.